Welcome to the third Prisma Meetup. This is our third edition of this meetup. And in this meetup, we try to bring talks on the wider landscape of application development, databases, and all things Prisma. I'm your host, Daniel, and today we have three speakers with some really exciting topics. Now, there's a fun fact that serendipitously, we discovered that three of our speakers share one very unique characteristic, which I will share very soon. So let me introduce our speakers. We have Alex DeBrie, Team Suchanek, and we have Matija Šošić. Now, our first speaker is going to be Alex DeBrie, who will be talking about picking a database for your serverless application in 2021. As many of you know, the rise of the serverless platforms has been really increasing in recent years, and choosing a database is not a tricky thing. So I'm really glad to bring Alex to the stage. Alex, welcome.
Hey, Daniel. Thanks for having me. Good to be here.
Good to have you here. So we just discovered that all three speakers share a characteristic. Do you mind sharing what that is?
Yeah, amazingly, all three of us are twins. So I have a twin sister and the other two have twin brothers. So yeah, pretty interesting to see that happen.
Yeah, that's great. Cool. Yeah. Well, I won't take any more of your time. I'm really excited about your talk. So you ready to share your screen?
Yeah, sure. Let me do that. Application.
Okay.
All right. Can you see my screen? Oh, there we go.
Yeah. The stage is yours, Alex.
Awesome. Thank you, Daniel. Yeah. So, as Daniel mentioned, this is talking to me about serverless. And if you've been around sort of the application development space in the last couple of years, you've probably heard about serverless applications, things like that. And that really got started in 2014 when AWS announced Lambda at reInvent that year. And Lambda is this pretty interesting new tool you have where you can just, you upload your code and it runs wherever you want in response to events. So which is pretty amazing. But again, you need events to sort of kick that off. So you have something like, maybe Amazon API Gateway, which hooks up HTTP endpoints to your function. So when people call HTTP endpoints with a get or a post or whatever, it can invoke your Lambda function. You'll do something with it and return to it. But just the code itself and API Gateway, that's not enough. Usually you need some sort of other service, which could be Amazon S3. Maybe you're storing or retrieving blobs of data, or maybe a queue service, right? You're enqueuing some data in something like Amazon SQS, or it could be any other number of services, EventBridge, Kinesis, SNS, things like that. But really, at some point, you're probably going to need a database, right? And if you're working within the Amazon world, there are a couple different database options. You have RDS, DynamoDB, DocumentDB. And that's what this talk is about. It's about choosing a database for serverless applications, because a lot of things about serverless are different than what came before it. So you need to consider some different factors when you're choosing that database. So I want to talk about a few different things today. First of all, we'll just talk about, your options in terms of data model. And I think, that's not super important, but the big point there is it just introduces the different database options that we'll be covering in the rest of the talk. The other three factors we'll have is, how managed is this database and how does that fit into a serverless world? Also, serverless integration. How well does it work with some of the quirks of serverless that are different, from running on instances or containers? And then finally, we'll get into the pricing model and how well that sort of fits into the serverless ethos. So who am I? I'm Alex DeBrie. I wrote the DynamoDB book, so I'm very biased in some sense in this talk. I like DynamoDB quite a bit, but I'll try and be fair and at least give you some of the pros and cons of DynamoDB and the other databases. I also created DynamoDBguide.com. I'm an AWS data hero and just a general AWS and serverless fan. I mentioned the DynamoDB book. If you come away from this thinking DynamoDB is the one you want to look at, go check out the book for sure. It's a pretty comprehensive guide to data modeling with DynamoDB with lots of examples, all sorts of things. So you can go sign up, get a free preview if you want. But let's hop in and let's start with, the different data model options you have and really the overview of just the sort of different options within those data models as well. So when we talk about data model, I think the big elephant in the room that you hear about a lot is going to be SQL, right? The traditional relational database. A lot of people know it. A lot of people use it. So let's talk about the pros and cons of SQL. First of all, a big pro is going to be familiarity. A lot of your folks, whether they went to code school or university or self-taught, whatever, they've probably used SQL in the past. They know that relational mindset, right? And they've used it at other companies, things like that. So it's going to be familiar. People know how to use it, good library support, things like that. Also with SQL, you get really good query flexibility. So if your data access patterns change over time, you've got that data set up in a normalized way that you can, write a new query and handle new access patterns in your applications. Some of the cons around SQL is, it's going to be a little bit harder to horizontally scale than some of the other options we talked about before. It's harder to shard your data. Although I would caution you a little bit there, that's not a problem for a lot of people. SQL databases are really good now. They scale up really far. There are certain people, Amazon, Uber, Lyft, whoever you're talking about there, that really do need the scale that NoSQL can provide. But a lot of people can get by with a SQL database. I think sort of more subtle about this is the scaling points are less predictable in a relational database. There are so many different parameters you can tune with a SQL database, or maybe different query optimizations you can make, or you don't know which sort of queries won't perform well. If you're doing big aggregations, they might work well at the beginning and not work well later on, where NoSQL is going to be a little bit more explicit in sort of how that scales. So I think that's one of the cons of SQL there. If we talk about the different options we have here, you can think of sort of the old guard options, proprietary databases. You see Oracle, SQL Server. I don't see a lot of that in the serverless world, just because, if you're using serverless, you're using a lot more, greenfield, newer tech usually. So usually choosing something like open source databases like MySQL, PostgreSQL. Like Daniel's joking about the elephant in the room, Postgres it's got the elephant logo. So these are pretty common with more modern applications, these open source ones. If you want to talk sort of in the middle here, you could look at Amazon Aurora, which is going to be a proprietary database that's only offered by Amazon. You have to, sort of use it as a service from them rather than running it on-prem or even on your own EC2 instances. But it does speak some of those open source dialects like Postgres or MySQL, so you can get those flavors if you want. So that's the lay of the land in terms of SQL databases. Let's look at the other sort of data model option you have here, which is NoSQL. And that's really a grab bag for a lot of different database types. That could be as simple as key value, but it could also be document databases, wide column, graphs, different things like that. Let's go through pros and cons of this type of database. So one pro might be, schemaless, right? You don't have to sort of declare all your schema up front or do migrations to add new columns, things like that later on. Some people really enjoy that. Also, it horizontally scales pretty well. So if you do have a lot of data or very high velocity data where you're going to need to scale pretty high, this is going to work well for you. And again, the scaling is easier to comprehend if you sort of understand 2 or 3 concepts about this database. You can really tell where it's going to break and things like that, and set yourself up for success in that way. The cons about a NoSQL database, again, sort of the flip side of the pro here is it's schemaless, right? So you don't know, it's hard to know what sort of data is in your database without really looking at it, in contrast to a relational database where you define the tables, define the columns, things like that. Also just generally less well known, right? You're probably not learning it in school or code school, whatever you did there. Maybe you haven't learned it at a prior company. And I also think there's a lot of bad NoSQL material out there, so you might go down the wrong road and really do something wrong there. So there's a learning curve there for sure. Finally, it's also harder to do like OLAP queries. So OLAP being sort of like large scale analytical queries, So if a PM or a biz analyst or something like that in your company wants to say, hey, what's the top selling item last week? Or who are our top 5 customers over the last 3 months? Easier to do in a relational database than a NoSQL database and things like that. So that can be a little bit of a downside as well. In terms of the options that I see in sort of a serverless application, that I'm going to put down 4. One is going to be the sort of big NoSQL one that everyone thinks of, which is MongoDB, right? It wasn't the first NoSQL database, but I think it was the first really popular NoSQL database, and that's a document store, very popular. If you want to go something in the AWS realm, you can look at DocumentDB, which is basically Amazon's own version of MongoDB. It's compatible with MongoDB, the format there, but it's more of a self-hosted solution or a fully managed solution from Amazon there. You can also look at DynamoDB. Again, that's the one that I've written books on and things like that. That's what I prefer. Again, within the Amazon ecosystem, more of a sort of a wide column store than a document store, but really good for a lot of things, picking up popularity. If you want to do a comparable one that's outside of the AWS Amazon ecosystem, then I'd look at Fauna, which is going to be similar to DynamoDB, has some interesting global features there as well, and some other features that are pretty interesting. So Those are the options for NoSQL. Again, SQL, NoSQL going to be the two different types of data models you can think about. Let's look at our first sort of factor that you really want to consider, and that factor is how managed is it? And to do that, before we get into it, I want to talk about like what I mean when I'm talking about managed and why that's so important in your serverless applications, why people are really liking that. So first of all, what I mean, maybe one aspect of fully managed is failover, recovery, backups, all that stuff is handled for me to where I don't have to think about it. And the reason that we're so concerned about that in the serverless world is that's undifferentiated heavy lifting, right? My company, my project, it's not going to succeed because I do failover and recovery better than anyone else. It's going to succeed because I have better features and a more interesting community or whatever it is than anyone else, not about sort of under the hood database stuff, right? So let's offload that to really good engineers, whether that's at AWS or Mongo or somewhere else, to run that for me, and I can focus on delivering the features that really matter to my customers. Another aspect of managed that's nice is just getting automatic updates. And why this is so important is like services improve without me upgrading, right? I don't have to log into my EC2 instance and stop my old version of Mongo and start my new one to get these new features. It's sort of just updating all the time, getting better for me, getting faster. With Lambda, that could be just the improvements they've done with cold start, things like that, the improvements they've done around billing time calculation, just all sorts of things. Lambda, SQS, those are all getting better for me all the time. I like my database to do that as well. Last thing we talk about with the what and why manage is auto scaling and pay per use pricing, right? And the big key here is I want to pay for value rather than pay for capacity, whether I'm going to use it or not. And we'll talk about pricing model a little bit more later on as well. So with those sort of principles in mind, let's look at how these databases line up, across a continuum here. On the far right, I might have fully managed. This is the ideal, what we want in that serverless world. On the far left, we have YOLO, right? You want to do it yourself. You're a cowboy. You don't want anyone managing it for you. You think you can do it yourself. On that far left, we have Amazon EC2, right? You can run your own instances, or maybe you have something on-prem and you're installing the software on it and running it yourself. I would highly not recommend that. Whether you're doing serverless architecture or something else right now, I think there are just so many good managed database options that you don't want to be in the business of really truly managing your own database in almost all cases, I think. So then if you move a little over on that continuum, you have what I can consider, the mostly managed databases. And this would be things like Amazon RDS. That's a relational database service. That's going to run MySQL, Postgres, Oracle, or my Microsoft SQL if you want something like that. You also have Amazon Document DB or MongoDB Atlas, which is a service from MongoDB that runs its database for you. These are really great in some sense. I think it gets you out of that EC2 world. This is really great. It's going to do a lot of that sort of failover and backup and recovery, all that stuff for you. But it's still not quite all the way there. To do updates and things like that, you might have to click a button in the console to do an upgrade. You still need to think in terms of instances and maybe add more instances or remove instances, things like that. So you're not quite in that fully managed realm yet. Next one over would be one called Amazon Aurora Serverless. This is a new-ish one. So they've had Amazon Aurora. They also have this serverless flavor that scales the compute up and down. They had a V1 version of that was just okay. V2 version just sort of came out at reInvent. It's still pretty new, but it's pretty promising and interesting there to where you get closer to that fully managed world. And then if you want to get all the way over on the right and really into that fully managed, that's where you see things like DynamoDB and Fauna that were really built for this serverless world. You don't have to worry about upgrades. You don't have to worry about pre-provisioning capacity and paying for idle and all that stuff. They're going to handle all backups and failures for you. You don't think about instances. So it really is, I think, the ideal if you're talking about serverless databases, those two, in terms of how managed they are. Let's move on to the next topic, which I'd say is like serverless integration, right? And again, serverless compute and applications are a little bit different than the previous world. So some of the existing databases and infrastructure don't quite fit as well in that world. So let's talk about some of those specifics and see how our databases fit in here. I think the first thing that's interesting to talk about is infrastructure as code, right? And this is a pattern that's been around before serverless started, but it's basically saying, when you're provisioning your infrastructure, your instances, your database, your S3 buckets, all that stuff, do it as code in this, often declarative way where you can spin up the entire thing and rather than someone going and clicking in the console and creating something, and now you have no repeatability around it. So infrastructure as code has been around for a while. I think the serverless world is particularly has really embraced infrastructure as code. And part of that is because with these serverless applications, your infrastructure is part of your application in a way that it might not be if you're using instances or containers. If you're using managed services like SQS or S3 or Kinesis or things like that, it really gets some application mechanics into your code that infrastructure does, and it's really important to sort of provision your new application code with your infrastructure altogether. In terms of like tools for infrastructure as code, I would say there are two really big ones. One is CloudFormation, which is an AWS tool and covers a lot of AWS services, but is not going to be so great at third-party services. And then one is Terraform, which is a third-party tool from HashiCorp. They do AWS, but they also do Google, Microsoft, but also sort of anything you want, Fauna, MongoDB Atlas, all that sort of stuff, which is really nice if you're outside of the AWS ecosystem. I would say for most of the serverless stuff, and again, this is coming from Lambda bias here, I would say most of the tooling has consolidated around CloudFormation because of the way some of the tools have packaged up your application code with your infrastructure as part of deploying that. So CloudFormation is generally the tool of choice for serverless Lambda-based applications. But again, you can use Terraform if you want. Based on that, I would say, if you're using CloudFormation, you might want to prefer AWS native databases over third parties. So things like RDS over getting your managed relational database somewhere else, or Amazon Document DB over MongoDB Atlas. Again, just for that infrastructure as code part, not that it's a total deal breaker. The other thing I would say when you're thinking about infrastructure as code is, prefer databases where you can do your full provisioning using that infrastructure as code rather than just partial provisioning. And the example I give here is, even if you're using something like RDS, or relational database service, you can set up a relational database using CloudFormation and get that all provisioned. But even after that step, there's something you need to do inside that database that you can't do within CloudFormation. You need to connect to that database and create users and roles and permissions, create your tables, create your indexes, triggers, whatever it is, all that different stuff. And that's sort of outside CloudFormation. So it takes like a different steps. You sort of have two different provisioning mechanisms going on. You can contrast that with something like Dynamo, where you can create the table, you can create your secondary indexes, you can create users and give them permissions on your table, all that stuff within CloudFormation. So all your provisioning is in CloudFormation, a single tool, rather than sort of having two different tools, two-step process, things like that. So in that sense, you might want to prefer Dynamo over RDS. The second factor I want to talk about with serverless integration would be auth, right? So how do you connect and talk to your databases? And if you're talking about the older, more established databases, relational databases, things like that, that's going to be username, password authentication, which is fine. But now you need to sort of store that credential somewhere. You need to rotate it. You need to make sure you're managing access to it and things like that. Whereas, if you're using Lambda and you're connecting with other AWS services, S3, SNS, SQS, whatever it is, you're probably attaching an IAM role to your Lambda function that gets temporary credentials just injected in that are limited to the access you give it, and you can use those automatically without having to really think about them in your code. If you're using DynamoDB, you can do the same thing, which is really great. So with auth, prefer services where you can use IAM over sort of username, password, managed credentials that you have to handle. Just again, it takes something else off your plate and allows you to scope it down a little easier, I think. There are a couple of relational databases within AWS where you can use IAM as well, so you can check that out. Last thing I want to talk about with serverless integration is the connection model, right? How do you actually connect to the database? If you're working with a traditional database, like a relational database or even Mongo, things like that, you often set up these long-lived TCP connections to your database and reuse those. And that worked great in the world of instances or even containers, where you're sort of spinning up this instance, preparing it, and then it's going to be taking lots of different requests. But the problem is with Lambda, you have all these little tiny compute instances spinning up all over the place. They're event-driven compute, which means they're only called and spun up when something actually has to happen. So you don't want to spend the time setting up this TCP connection, doing things like that. Also, you have to run into connection limits, right? A lot of databases, Postgres, MySQL, will limit the number of open connections you can have because it takes memory on the server to have those connection limits. So Postgres, MySQL might have 100, 200 connections they allow at one time. Which means if you have too many Lambda functions spinning up all over the place, you can actually hit your connection limit and not be able to connect, which is a huge disaster. This is partially solved with another tool called AWS RDS Proxy, which is basically like a connection pooling instance that you can connect to, and that's going to manage connection to your database. It's like a PG bouncer, if something like if you've heard of something like that. You can run your own one of these. This is sort of newish, so again, test it with caution, but that can help solve this limit. Even if you solve sort of the connection limit issues, you still need to consider things like VPC, security groups, ports, all sorts of access like that. So you're locking down your database to just the IP addresses you want. It doesn't quite fit really well within a Lambda world. You can put Lambdas into VPC and give them security groups, but there's some clunkiness around that. So there are some issues with traditional databases with that sort of stuff. If you're working with DynamoDB or also Fauna, it uses HTTP connections, which means you don't need to worry about connection limits, right? They've got basically a front end that proxies to Dynamo and can handle as many connections as you want. You also don't have to worry about long-lived connections or connection limits. You don't have to worry about security groups and networking and all that stuff. That's all done over HTTP, and the authentication is IAM, so you don't have to worry about it. Fauna, very similar. So again, a nicer sort of connection model for this stuff. Last factor I want to talk about is pricing model, right? And in your serverless world, serverless architecture, you generally prefer pay-per-use pricing. And a lot of very common services in the serverless world are all going to be pay-per-use. Lambda, you're basically paying based on how much memory you've allocated and how much time your function actually runs. SQS, you're paying per message. API gateway, you're paying per HTTP request, things like that. Where pay-per-use is difficult, then you prefer something like easy auto-scaling. Maybe pay-per-use isn't doable, but if you can at least scale up and down as your traffic sort of ebbs and flows over the day or week or month, that's really great. So again, let's look at our databases on a continuum from how well they do pay-per-use versus not. So let's start with sort of instance base on the right side, which is going to be more like how you pay for EC2 or things like that, where you're saying, hey, give me this size instance, at the beginning of the month, and at the end of the month, they'll send you a bill for how many hours it was running. On the far right, we have pay-per-use, which is going to be more like Lambda, SQS, anything like that in this sort of native serverless world. A lot of databases are going to be in that instance-based world. Amazon RDS, Amazon DocumentDB, MongoDB Atlas. You're going to tell them how many instances and how big, and they're going to run that for you and charge you per hour. And it's fairly hard to scale up, and it's even harder to scale back down just because of how these databases work. So you're going to be sort of stuck a little bit these. You're probably going to be overpaying for capacity because you're not going to get sort of full usage out of that just to make sure you can handle spikes. More in the middle will be that Amazon Aurora serverless, which we talked about before, which allows you to sort of scale up and down your compute in response to actual traffic that you have. Again, the V1 version was a little slow in how quickly it did that. Not great for a lot of production use cases, but the V2 version seems to be better. I'm still sort of crossing my fingers here, but check that one out if you want something a little more flexible, but you still want that relational model. And then on the far right side, again, we have DynamoDB and Fauna, which both have pay-per-use pricing. You can actually just do on-demand pricing and say, hey, just charge me for every read and write that comes in. You don't have to pre-provision stuff. It's going to handle all that for you and pay you for each read and write request that comes in, which is pretty amazing. So that sort of concludes it. I'm going to summarize it and give you the sort of TLDR. So again, just to review what we did here, first we looked at the data model and just sort of different options we have in terms of databases. Then we looked at three big factors, right? How managed is this database and how much do I have to do? How well does it fit into the serverless ethos that way? And then serverless integration, right? Lambda and those other services, they have some quirks around how they work compared to container-based, instance-based stuff. So how well do these databases sort of fit into that serverless world? And then last one, pricing model, right? We really like pay-per-use, pay-per-value in that serverless world. How well do these different databases fall into that? If you just want to know, hey, you gave me all that stuff, but really, what should I choose? Again, I'll try and be fair here. If you want to go the most serverless native, I'm gonna recommend Dynamo. I think it fits really well in terms of the connection model, in terms of how it scales up and down, in terms of the pricing, the IAM, the provisioning, all that sort of stuff. I think Dynamo works there. But again, I'm biased on the Dynamo guy. But I think you are going to have to learn some things, learn some new things if you're using something like Dynamo as compared to relational, and it doesn't fit for all use cases as well. So if you want to go like most familiar and say, hey, we want to be productive right away, we want to get going, all of us developers already know SQL, then use something like RDS and maybe RDS proxy, right? It's RDS, it's still in the AWS ecosystem, you're getting all those benefits. RDS proxy is all managed for you. It can sand off some of those hard edges around connection pooling, stuff like that. That can work really well for you. I think that's a nice, safe, conservative pick there. If you want to go more cutting edge, then you can check out Aurora Serverless, especially that V2 has some pretty interesting scaling characteristics. Look at Fauna as well. They're doing some really interesting stuff with like global database type stuff and what that looks like with the global consistency. I think they're doing some really interesting stuff. You're stepping outside that AWS world, so you're going to have some edges you need to work on there, but I think they're doing some interesting things. If you do want to look into Aurora Serverless V2, I would highly recommend Jeremy Daly's post on this, that he just really did some interesting scaling look at that and what that looks like, how that improves on V1. Super interesting. So make sure you check that out before you dive in. And yeah, that's a summary. I can answer any questions. If you want to check me out on social or my different resources, check those out. But other than that, yeah, happy to answer questions for a few minutes before we move on to the next talk.
Alex, thank you so much for the insightful talk. I think we had a couple of questions come in from the audience, and I think the first one touches on real-time and kind of like having open WebSockets type functionality. So Ahmed asked, I don't know if you can see the question, if I'm making a social media app like Twitter where there is some real-time stuff happening, is serverless the way to go, or should I stick to traditional serverful?
Sure. That one depends a ton just on the specifics of the use case. If you really want to use something like WebSockets and you're maintaining this open connection, well, AWS does have a WebSockets mechanism for connecting, basically API gateway to Lambda and doing WebSockets and broadcasting sort of both ways there. So you can check that out. In terms of other real-time features, are you doing polling versus are you doing sort of stream-based stuff and broadcasting? I think there's a lot of interesting serverless stuff there. It's hard to give a generic recommendation like that because even Twitter, I think that's doing polling. It's not sort of doing WebSockets, things like that. So it depends on what sort of use cases you want. But I think a lot of the building blocks are there in a serverless world if you're willing to pick up how that stuff works. Great question.
Now, we had another question, which I think is going to be a bit difficult to answer, but someone asked, Daniel asked, I deployed a serverless Lambda app connecting to a database hosted somewhere else. The performance wasn't really great because new DB connections needed to be established for every request. So this is one of the more common problems that come up in serverless. Yep,
sure thing. So again, it's going to depend a lot on sort of what that database configuration was. I can give you a couple examples there. Like if you're using DynamoDB, I said, you need that's HTTP connections. Well, establishing that initial TCP handshake can be not super slow, but it's going to add 100 milliseconds or two on each request. If you sort of reuse that connection, it's just going to happen on the first request, and then everyone after that for your Lambda will be faster. If you're working in a serverful world, right? If you're doing an instance-based database like Postgres or Mongo or something like that, it could have been. This is getting kind of deep in the weeds, but if you had to put your Lambda function in a VPC so that you can allow like security group access and lock it down IP address wise, there used to be this cold start penalty for Lambdas in VPC where it would take a long time to do that, specifically if it's in a VPC, which I wouldn't recommend doing. They've made some improvements around that, so that could be faster now, but it could just depend on what your database is and some of the quirks around that. If you have like more specifics on that, like hit me up on any of these places and I'm happy to like give more advice on that. But hard to say without knowing specifics of the details there.
Yeah, and probably on the note of like generic advice in this context, I would probably say deploying them in the same region is like the very sort of high level recommendation that I would make.
Yep, absolutely.
So very interesting. So you've written this DynamoDB book and you seem to have quite a lot of experience with it. Yeah. As someone who's so familiar with it, what are some of the disadvantages that you sort of see beyond just level of familiarity and having, using a proprietary technology?
Yep, sure thing. So I think that's the big one is just like familiarity. Like people don't know how to model in a NoSQL database, and especially one that's like Dynamo. So I think they try and do it like a relational database, and that ends up really hurting them. So that's one thing. Two other ones I would say is it's not going to be quite as flexible as maybe a relational database. So if you have changing access patterns, it can be a little harder. You might need to reshape your data a little bit and sort of do some modification of the records in your table. Also, if you have access patterns that are I would say, like, if you're filtering on a ton of different attributes, or maybe like more than 3 attributes and all of them are sort of optional, it can be hard to sort of map that into DynamoDB. So imagine you had like a CRM that had all these different categories: last name, first name, age, location, have they used this service, different things like that. If you want people to be able to filter on all these different categories, it's not going to be as great for that. It's more for like specific known queries. So make sure you're researching around that. I would say in general, it can handle 80 to 90% of the use cases really well, and just make sure with those other ones, like, can you work around it? Do you need to use something else, or sort of what's the situation there?
Gotcha. Thank you for that. And one final question: is it possible to spin up some kind of like a local development instance of the DynamoDB?
Yep. Yeah. So they DynamoDB actually has what's called DynamoDB Local, which is like a little Java jar that you can just like run locally and use it you can use it in your sort of local integration tests if you want to, or just as you're developing. It's not going to have all the features. It's got most of sort of the API implemented, but it's not going to have the availability features and things like that. But it does give you a nice way to sort of develop against that API locally without charging, and also without having to like destroy the infrastructure all the time.
Gotcha. Well, Alex, thank you so much for coming here and giving this talk. And I hope to see you soon at perhaps another meetup.
Sounds great. Thanks for having me, Daniel.
All right. Okay, so we now come to our second talk by our very own Tim Suchanek, who will be talking about Prisma in React Server Components. So Tim probably needs no introduction, but I will do one anyways in case you're not familiar with some of his work. So Tim is a software engineer from Sauerland in Germany originally. He studied computer science at the University of at the Karlsruhe Institute of Technology, and he's passionate about startups and new ideas, which brought him to Berlin. And he's been with us at Prisma since 2016, where he leads the TypeScript efforts. So now I bring you Tim.
Hello.
Hello, sir. How's it going?
Hey, Daniel. Good. It's a bit cold in Berlin, but it's good.
It's getting slightly, the days are getting longer, which is quite nice, I find.
That is true. Still a bit bright outside.
So last Christmas, you didn't give me your heart, but we had a lot of excitement around React Server Components, and now you're going to give us an introduction to how Prisma fits into that. Is that right?
Yes, correct. Yeah.
Okay, cool. So I'm going to share your screen, and the stage is yours.
Okay. Yeah, thanks, Daniel, for the introduction. Thanks for having me. And hello from Berlin. I'm Tim, and working as a TypeScript lead at Prisma. And so right before Christmas last year, was the 22nd of December, there were news in the React ecosystem. Concretely, React Server Components have been announced. And today I will talk about how they're related to Prisma and why this is really exciting for the Prisma ecosystem to integrate into this. So we had this, So we had this tweet from Dan Abramov, 22nd of December, where he said, "How is this not illegal?" Where he had a SQL statement where he just had like select star from nodes, and then he was directly using that in a React component. And you might say, oh no, you cannot just use SQL directly in a React component. This looks so dangerous. You might be able to do SQL injections and so on. So Nico, our who is working in DevRel at Prisma, he directly posted this Drake meme and basically said, hey, you should not do SQL. You should instead do a Prisma query. And so we will now talk about today what does this even mean? How can you run SQL in React. Why does that even make sense? And what are these React server components about? So the first initial reaction that I saw from many people is, it's just PHP. And that is not the case. So why is it not just PHP? So if you hear the term server component, you might just think, okay, it's something rendered on the server, that's it. And that reminds many people of PHP or also other frameworks in which you are rendering server-side, like Ruby on Rails. So why is it not just that? There are two main points. So on the right side, we have these dots here. And let's say orange is the server components, blue are client components. So first of all, to define server components, we need to define what are the components called that we are writing today, the React components that we write today. They're called client components. With that, we mean they're shipped to the browser, to the client. And any library that you're importing there is completely shipped to the browser. Like, let's say I use a date library that has like 20, 50 kilobytes. Then I am always shipping that to the browser, although I might just want to like render a little date and a date field. And so what is possible now with the React server components is that in the root, you can have a server component that's rendered on the server. We will later go a bit more into detail what that means. And the interesting part is now that a client component can be a child component of that. And again, a server component can be a child component of the client component. And so you basically can have this mixed tree. And you as a developer, you don't need to care. React just takes care. And so what is happening if I'm rendering a client component and let's say I'm clicking on a button and I now want to render a server component, what is actually happening is that React does a request to the server component, React server component backend, and is rendering that markup in the server, sends that markup back to the browser, but no single JavaScript dependency is being sent back, but just a pure markup. Pure markup means, also here I can say that directly, that means we cannot do anything dynamic and like a dynamic input with an event listener or something like that. That is not possible. In server components, however, we can do quite a lot, and you will realize in your applications maybe even a majority of the components can be server components. So that is one point. The other point is why this is not just PHP, is streaming the component back to the client. So what does that mean and why is this interesting? Let's say we have a component that needs to fetch from some really slow API some data. And so what it can do, it can directly return already like a spinner or some skeleton or something like that. And in the meantime, fetch the data. And then once it's done, it will actually return the full rendered component. And this can be basically streamed to the client, again, something that's in this traditional PHP model you would not be able to do. We will later go a bit into this streaming protocol because it's quite fascinating. So why should we even do this? So the big trade-off that we have here is developer experience versus performance of our application. So the React team, they got a lot of feedback, and they had, I mean, in these many years of experience now, had a look at how can they maybe find a new trade-off between developer experience and performance. So performance, if you, for example, use GraphQL, but you don't have to use GraphQL, you can use a library called Relay. That is a very optimal performant library that helps you to fetch data in an optimal way and maybe already pre-fetch data that it knows you need later. And you can use Relay. That also helps a lot with performance. But not everyone wants to use Relay, and it is, let's say, a bit opinionated, it forces you to use a certain architecture. If you want to use that architecture, it's good, but it is for sure, there's a learning curve involved. And now the Facebook team is using Relay. Why are they then still interested in the server components? Another big point are dependencies that we don't want to ship. So if I have a date library, like date functions, for example, I think they're around 20 or 50 kilobytes minified. So if we use that library just to print one single date somewhere that we want to format, we in the traditional React model would have to ship all of that to the client. So we now added like 20, 50 kilobytes to our bundle, which makes our whole application slower. And last but not least, the big point of Relay is really to prevent request waterfalls or round trips. So what do I mean by that? I have a little example here with my limited design skills. I made this little mock-up here. So let's say we have an application with a list view and a detail view. And so what we would want to do is we want to first get the list view. Maybe the list view is even depending on some search query. And depending on what is the first post, that particular post we want to show in the detail view. So if we want to now fetch the data for that, we would first fetch the data for the list view. So we have run round trip. Let's say we're in a traditional React model. Yeah? We do a request from the client to the server. So we have this round trip. After that, the client now looks into the posts and says, the first post, I want to render that, and I need to detail information of that post now, because we not always want to fetch all the detailed information of all posts. Maybe we want to fetch the comments, for example. So we have another round trip to the server and get that detailed information for that post. So we have these two round trips, and that is basically the request waterfall. So you could even go levels deeper. Yeah? Again, if you would now, in a third step, maybe even get the comments, it gets worse. So we're adding up all of these request times, which is not what we want. That is something Relay can make very efficient, for example. And this is exactly the problem that is being solved by server components. So, and by the way, regarding the streaming interface, the React team specified, they wrote a spec for how to stream this kind of data that you would get from rendering a server component, how to stream that to the front end. So it's not just where they are not just sending like HTML tags, they actually have a quite smart streaming interface. So this is how it looks like if you open the network tab in a React server component application. So we started again with this Drake meme, and it was just before Christmas. And a few weeks after that, at Prisma, we said, hey, this is a perfect opportunity. Because why? Because you can directly use Prisma from the front end. That has not been possible before. So we should look into this. So that's what we did. And so the official demo from the React team is called the Server Components Demo, where they have a note-taking app. We will have a look at that in a bit, where they really show exactly this wireframe also that I just showed to you, where on the left side you have the articles or the nodes, and on the right side you have this detail view, like a master detail view, basically. And so at Prisma, we were also a bit busy. We created a so-called React I/O library. So in this server component paradigm, you kind of need to be able to access data. And in order to not need an await statement in your component, we will get into that in a bit, you need to create like a dedicated wrapper library for anything that is I/O. So the React team, for example, created one for Postgres, and it's called React PG. Also for the file system, if you want to read something, React FS. And we created React Prisma. This is used to query data. In a bit, we will also get into how mutations work in this setup. So yeah, you can check out this demo. It's at github.com/prisma/server components demo. And so what was really awesome to see, in January, we had a stream where we showed this early prototype of this React.io package, and actually Dan Abramov and Lauren Tan, who have been working actively on this topic, they joined our stream and even answered questions, and that was really awesome to see. And we are now in contact with them and try to make sure that the React.io, that the React Prisma library is always up to date with the latest React server components. And also here, I just want to say, as we do here in the README, this is highly experimental. The timeline is roughly half a year or a year to get this into production earliest. So this is really an outlook into the future, and helps us to see the vision, to see how you will be able to use a Prisma client together with React server components. So again, why is this exciting for Prisma? Because you don't need any API layer between your server and your client anymore, because it merged into one, which is great for many, many use cases. That makes it easier to get started. Again, in the tweet that Dan Abramov did, he said, like, this is illegal. I cannot just do SQL directly in a component. And that is obviously a great opportunity for Prisma, because Prisma as a data layer, rather, instead of just as a simple database low-level client, has a great opportunity to provide permission logic, privacy-aware features. Prisma is actually working on things there. And that means front-end developers can directly use Prisma without the need to learn GraphQL, for example. But we talked enough. Now it's time to actually demo. So Inception. I have this demo open here. So this project here that you can see is the server components demo from the React team. They used the React PG library in order to access the database. There's some database access involved in this demo. In our case, we replaced that with the Prisma library. So let me just check. We should have the demo open here. Yeah. So let's first have a look at the demo. So this is exactly the setup that I showed you on the wireframe. On the left side, we have the nodes. On the right side, we have a detail view here. So we can, for example, create a new node, and we can say it's called Hello Prisma Meetup. And we can say, we can even put some Unicode in here if we want to, blah, blah. And that's done. Perfect. And on the left-hand side, we can now filter if we want to. So yeah, that's the demo. Now, the question, how does it work? So the entry point to this whole thing is a server component. It's not a client component. And this server component is called app. It gets passed in certain props. How these props exactly get in there, you can have a look at the demo. It's a bit more involved right now. So again, it's just a prototype. But basically, this is rendered on the server, and the server root is basically passing in these props. So you have like a shared state on the top, and then that can be used in these child components. So for example, we have a search text. The search text comes from the search field, for example. So how does the search field work? It does something called set location. And use location is something custom, like you could basically say it's a kind of context that the client can set to communicate to the server. So let's just assume it's kind of set state, and we're able to set this here in the ordinary on-change listener of the search input. So this component here, and also, by the way, how do we distinguish between client and server components? A client component just has the convention.client.js, the server component.server.js, quite simple. So then the Webpack compiler, they have a custom Webpack plugin, will differentiate and will make sure that the server components only end up on the server. They will never be shipped to the client, and only the client components are shipped to the client. So again, the server component is the root of all of this. That's basically what we see here. And so how do things get updated now? So again, we're setting this location thing. There is some magic. Let's just assume this is solved if you would use this, let's say, in Next.js or Gatsby, whatever, in the future. So this is the setup we have. The search text gets set properly, and now we can render actually the list. So the list view that we have here on the left side, this part here, how is that rendered? So here we now use Prisma. This was the example where they used Postgres directly with SQL, but here we use Prisma. And as you can see, as usual, you have the type safety. So we have this JSON query API, as you know it from the Prisma client, and can now basically query for the search text here and filter the nodes based on the search text, which is, by the way, always case insensitive. So if we, for example, say Prisma lowercase, then it will work. And so this looks like magic. How does this work? There's no await statement, nothing happening. So I try to give you a very quick explanation. The idea is that this code here, if it is not if it's not a resolved promise, throws. So this is throwing a promise, this code. React then basically catches that, waits until that promise has resolved, and goes back and actually renders the stuff here. Yeah. So that means line 21 is not even executed as long as this is not there yet. So yeah, that is basically how it works. A bit crazy. Some people are criticizing it and say you should just use await. But I don't think that this is something that will still be negotiated or changed. This is a conscious decision of how the React team made this happen. And this is basically called React IO, this kind of setup here where you have this magic API. It looks like, hey, how can this be without an await statement? And so where do we get this Prisma from? This Prisma comes from the package React Prisma, and that just wraps the Prisma client. You can, by the way, check this out on github.com/prisma/Prisma. You will find the React Prisma package in there if you're interested in how the implementation looks like. It's a fairly thin wrapper just around the Prisma client. So, but now we're just doing queries here. How do mutations look like? So let's say I'm creating a post. Yeah. So again, we call this untitled2 and blah, blah, blah. How does this work? Now comes the really genius part. So again, the React team wants to make this performant. And instead of, like, how would you do this now in ordinary React client application? You would probably do a call against some JSON API, and then you would maybe like post against that API. And then you would get back some JSON, and then you render the component based on the JSON that you get back. And here it's different. In order to make things even more efficient and not unnecessarily render like ship code again, like for example for the date library here to the front end, if we post. And this is the post call to /nodes, which, by the way, that's the API server. It's implemented here. It's a simple Express application, tuned a little bit. They added some stuff on top. But if you do that, you directly get back not the JSON, but you get back the rendered post. So with that, they're directly saving the step of maybe also having to fetch other data, whatever. It's directly returning the markup, basically. That is the genius part here. So mutations, the idea is really that mutations are directly returning the rendered markup, and it will directly be rendered into the browser. So you don't even need to do, let's say, cache invalidation if you use Apollo client or whatever. It's just directly rendering the markup, so that's not at all a concern. So in this Express setup here, so we are here just calling the ordinary Prisma client API. And so in this case, we are both writing into a file system. So in this demo, they chose to write the data into Markdown. So you have like a little bit like a blogging experience with Markdown, but on the other hand, it's also saved into the database. And so how does this magic send response function work? This is the function that returns this rendered tree. So this function, again, sets this location. The location is basically kind of context or state that is shared between the client and the server. And they are actually rendering a whole React tree. Again, that is this streaming interface now here. So they're piping that into the output here and into the response. And with pipe, this is really allowing us to stream results. So what we could do in our mutation, we could be able to say we already send something back, maybe like a spinner or something again, and then we would later render the actual data once we're done. So yeah, that is basically how you can use Prisma Client today with React Server Components. As you see, this is JavaScript. This is not yet TypeScript, so a lot of work still has to happen. This is a new territory for the React team because, as you can see with the client and the server.js, we are now getting into bundling territory, which was something that the React team didn't have to do before. So they are still figuring out how to do things, how to package things, are working together with the Next.js team and so on. But yeah, we're making sure that this React Prisma package is always up to date, and you can check it out today. So you can just go to, let me see, you can just go to Prisma, github.com/Prisma/server components demo. Yeah, that's it from my side. Daniel, I cannot hear you.
I'm sorry about that. Yes, so I wanted to say thank you again for the talk. That was insightful, and I think a good refresher on the current status since the last time that we've spoken about this. So we're open to questions. Please use this moment if you have any questions regarding Tim's talk. And I have an immediate question that came up while you were presenting, and I wanted to hear your thoughts on. So if you use server components, does that mean that you essentially need to maintain an open connection to the backend?
I think the connection, it's like still request response based. So if the client finds out I now need to render a new server component, it would basically do a request in that moment to the backend. So that's also really interesting in order to understand it a bit more. Just checking out this Nodes demo, opening the network tab. I had to do it myself, and then you just click around a bit and you see what requests are actually being performed. Yeah.
Okay, and then we already got a question. So DB polling.
I mean, I guess if you want to have DB pooling, I think nothing really changed. Let's say you are deploying this to Vercel or whatever, some serverless environment. It's the usual business. If you want to have DB pooling, you can put whatever PG bouncer or something in front of it.
Mm-hmm.
Yeah.
Okay, Ahmed asked, so the idea of server components is to get rid of the API layer. Isn't Blitz.js already doing that? Oh, that's a great one.
That's a great one. So yeah, about that, how does this actually fit into the ecosystem? I didn't mention it. So first of all, Blitz is on top of Next.js, and let's first talk about the Next.js a bit. Next has two nice properties, one called get server-side props and the other one get static props. So why do we need server components if we already have get server-side props? Get server-side props is just giving a component its initial props, but that component is still a full client component that can do interactive stuff like an event listener, and you're still shipping that whole component to the client. And that also counts for Blitz. Blitz is still shipping client components, and Blitz is still, like if you have this request waterfall situation, you will still have that with Blitz. You will easily run into that. So yes, it looks like there is no API, but actually Blitz is under the hood just doing HTTP requests. And I think with the server components, if you can use them, you are, let's say, a bit more prepared to not get into these performance pitfalls.
Cool. So if there's no more questions coming in, I'd like to thank you again, Tim, for the talk.
Yeah, thanks for having me.
See you soon.
See ya.
Okay, we now come to our last talk for today. We have Matija Šošić, who will be talking about Wasp, a DSL for building web apps with Prisma, React, and Node.js. So in case you're not familiar, Matija holds a master's in computer science from the University of Zagreb in Croatia, where he's also joining us today from. And he's an experienced software engineer with experience in various areas, from writing bioinformatics algorithms for GPUs to web development and compilers. And currently, Matija is working together with his twin brother. So as we mentioned in the beginning, 3 of our speakers today, Tim, Alex, and Matija, they all have twins. They're all twins. So Matija is working with his twin brother, Martin, on Wasp, and they are Y Combinator backed, and they have the goal of streamlining web app development. So without any further delay, I bring you Matija. Hey, how's it going?
Hey, hello. Do you hear me? Is everything okay?
Yep, we can hear you. Everything is working smoothly.
Okay, awesome. Thank you, Daniel, very much for the introduction. Very kind of you. You were like said majority of my presentation. Just kidding. So let me just share the screen.
Did I get the pronunciation of your surname right?
Almost. Like it's similar to sausage, so close enough.
All right.
US people are always having a good laugh with our surname. So yeah, sharing a screen. Okay, screen number 1. Okay, cool, some inception. And yeah, you can see it now, I guess.
Yeah, all right.
Awesome, okay, awesome. I will
Matija?
just move you to this side. Okay, cool.
All right, the stage is yours.
Yeah, and I will just go full screen. Okay, awesome. Everybody, thank you for coming. So this is our first time actually presenting Wasp in public, so I am excited. And yeah, let's see how it goes. So Wasp is a simple language for building web apps 10 times faster. And yeah, it works with React, Node.js, and Prisma. So as Daniel kindly said already, like he gave a bit perspective on our background, but I will also give a bit more. So the team is currently my brother Martin and me. We are twin brothers. And we are both computer science masters here from Zagreb in Croatia. And during university, we worked in different companies, had our internships from Google to Palantir to Noom in New York. We were also associates in Techstars, helping the companies in their batch. And we were also both in Singapore working on ML algorithms, and I was working on GPU algorithms for bioinformatics, so that was pretty exciting. So we were kind of always more on the deep tech side, but kind of whatever we kept doing, we always actually ended up developing web apps, because it's always like inevitable part of whatever product. So we also had like a lot of experience with building web apps. So, and I also forgot to mention, like we are an open source project, so we also have some contributors. So it's about like us plus about 5 to 6 contributors who are also helping with the code, and it helps a lot. So why Wasp? So as I mentioned, like the main reason is actually we had a lot of experience with going to various technologies, and it's coming like we also had like a lot of frustrations. So we started with kind of building our first web application with PHP and jQuery. Then also on the front end went through Angular, Backbone, and now ended up with React. And also on the backend side, we use different stuff from PHP, Java, Python, and now most lately we have used Node. So we always kind of felt, that we were always building somewhat similar products, like for the web applications. You always have to build a notification, routing, pages, like all that kind of similar stuff, and it was pretty like repeating itself. But we also always had to relearn the new technology every time we were starting a new project. So we felt like that is a lot of work for something which is kind of always similar from the outside. So this was the main motivation with Wasp, and basically we set for ourselves the goal that we want to accomplish with Wasp, and that is we want to make it possible to write less boilerplate code. We also want to ensure the best practices and enforce them as much as possible out of the box, because we also found it pretty hard to find the best ways to connect different pieces of stack. Sometimes there even aren't yet the best practices defined. So there's a lot of work just to figure out what actually is like the good and solid approach for the future. And the last part is actually we want to separate as much as possible the specification of the web application. This is what I mentioned before. What are the requirements, what we actually want the application to do, from the actual implementation. So how does it do it? Is it in React or Angular? What are the details of the implementation? So also a bit more about the current status. So we released alpha version in the last, this December, and now we have more than 100 projects created with Wasp, and we also have first deployed apps. And yeah, we have also been backed by Y Combinator, so we have some initial funding, which gives us opportunity to work on this full time. So we are super excited to see what we can do. And yeah, we are right now in the batch. It lasts for about a few more weeks. So yeah, it's all exciting. So also to give you a bit more visual timeline on what was going on with Wasp. So we started about a year ago, and if you can see this pretty horizontal slope was the whole part of us working on the prototype, figuring out the features, working with other developers, seeing what they want, what they need. And then basically around December, we released Wasp Alpha. And this is when we actually started getting some serious traction. People trying it out, using it for their side projects, using it on hackathons. And then this last part, last spike, was actually our Hacker News launch, which was also pretty successful. And people were super positive and gave us a lot of good feedback. So very grateful for that. Awesome. So now I can actually talk a bit more about how it works. So let's see. Just super basic information. So I said it's a programming language, but actually it's a DSL, so domain-specific language. It's not a full Turing-complete programming language, and we don't intend it ever to be. So the main idea is for you to describe high-level features in our Wasp DSL, and that is, as it said here, authentication, routing, data models, queries, actions, or mutations. They're often called. And then you also write your specific logic, view components in React, and then Node.js for your queries and database actions. And we are now also using Prisma for modeling, data modeling. And all this at the end compiles right now to regular React and Node.js application. But also the cool thing is actually we have control in what is actually being compiled. So we could also in the future support other technologies and other architectures. So this is also something which is interesting potential. To give you a bit more of a visual overview of how it works. So this is actually what I spoke about before. Oh, you can see my mouse. That's great. So here are Wasp files. There can actually be multiple Wasp files very soon. So here you can define those high-level features, which I mentioned before. And then actually React files and Node files, they serve for writing specific logic. So, and this Wasp logic actually is a glue between the view components and your database queries and mutations. And what happens in the under the hood is basically our Wasp compiler takes all of this in and spits out the full application code in React and Node.js. So we cover both front-end, back-end, and deployment. Right now, we don't have yet AWS deployment, but we are supporting images that can be deployed on Heroku or some other similar service. Yeah, we're using Prisma for the database. And I mean, the whole idea is that you don't have to touch this generated code. Ideally, you would never touch it. But in the case, especially now in this alpha stage, if Wasp is not flexible enough, you can actually take it away and just continue with it. It's actually we put a lot of effort to make it human readable. So people are actually often surprised how readable it is. So for now, it's pretty simple to take it out and continue if in case Wasp is not yet mature enough for your use case. Cool. And yeah, this is what I said. So just to give you a little bit of feeling of how the code works. So this is the sample of the Wasp code. So as I said, like it's a DSL, and in fact, it's like a simple configuration language. It's similar to JSON at some point, just maybe a bit nicer at the moment. So for example, you could define like some basic properties of your application. This is the example of routing defined here. And this is actually like this highlighted green line. You can see how you can reference your outside code from, in this case, from React components. And then we also offer authentication support. So we have like several methods. You can choose which one you want, like which data model is going to serve as a principal or a user. But we are going to see this all more in the action soon. And yeah, Prisma, as I said, like is a very good fit for Wasp because it's also declarative, and Wasp is aiming to be very declarative. So we are pretty much now using Prisma directly for data modeling. So here we just like have our own keyword for entity, which Prisma is calling a model. But like all this inside this parenthesis is actually just PSL, Prisma Schema Language. And then we are using that directly to just forward it to Prisma to take care of the database. So this is super handy. And yeah, we are happy that Prisma is doing all this heavy lifting for us. Awesome. We have actually quite quickly come to the demo. So in this demo, I will show you, so we are going to build a simple to-do application, and I will show 2 use cases. Now, it depends on how much time we are going to have, but it might even be enough. I'm going to show how we can do authentication in Wasp, and the second part is going to be more about standard code. So we are going to create some tasks and then list them. Okay, cool. Let me now just exit this. Yep. I'll just move this to the left. And I believe you can see my terminal right now. Okay, great. So we will just start with creating a new project. So actually just to show you first how to...
Matija, can you make your font a bit bigger so that the audience can see?
Yes, sure. Let me just see how it is done. Preferences, I guess. Preferences, appearance.
I think Command plus, if you're on a Mac, Command plus should do that.
Command, actually, that's a good idea. Oh, awesome. Wow, you're a hacker. Cool. Let me just try to, my Tmax got a bit, great. Okay, actually, I just have to do it like this. Okay, cool. So the first thing we have to do, I will just show you how to actually install Wasp. So you will just go on our website and copy this curl. And if you don't believe the curl, you can also build it yourself. So all you have to do is paste it in your terminal. So in my case, it's not going to install it because I already have it installed. So it's like giving me a warning. But in your case, everything is just going to work smoothly. Cool. So we have done this, and now similar to like other tools, we can just write Wasp, and we get all the commands to get started. So we are going to do Wasp new. Let's call it. Let me just check the status. Okay, we are good. Let's call it to do. And now what's created for us the new project. So all we have to do is enter this project. So let's see what is in there. So here we can see, as I said, like this main Wasp file, and we already have like scaffolded several files for us to get started more faster. So all we have to do is run Wasp start, and now it's going to take about like 30 seconds because it's doing it for the first time. So please bear with me. So I mean, what is it doing now in the background? Actually, it's running npm install for the first time for both server and the frontend server. So this is why it takes a bit, but it's going to be much faster once this is done. Cool. I will in the meanwhile prepare. You can move this. I'm going to prepare my Visual Studio. Great. Yeah, so we are for now directly piping all the output from web application server and backend server here. Probably going to make it a bit more verbose in non-alpha, but for now you get all the information. Cool. So we can also, maybe should I also, let's see, enlarge my code here. Okay, cool. So we can see here the main Wasp file, and let's also share this one. Now let me try to make it bigger. Okay, let me know if you want it even bigger. And yeah, I think in the meanwhile our app was served. Cool. So now we can just go to localhost 3000. And yes, we can see it here. So here's actually like just a starting page, welcome page of the application, and we can just take it from here. So I would now just go back to. Oops, sorry for this. Let's go back to the code. And yeah, as I said, like let's add authentication to Wasp. So this is how we are going to do it. So we are going to there is a special command as I showed you earlier. So I will just copy it over here so I don't have to type it. Okay, so basically this block defines how is authentication going to work. So it says, okay, it's going to work like we need to have like an entity called user, which is going to serve as a user or principal entity. And we are going to support email and password as a method. And in case somebody tries to authenticate and it fails, it's going to redirect him to login route, which we also don't have yet. So we are going to have to make it. So let's start actually with creating our user entity or data model, basically. So we'll just put it here. Now, as you probably know from using Prisma, we have to do database migration. So I just have this other terminal for that here. And the left side is currently crashing because it's complaining because we haven't done yet the migration, but this is going to be fixed soon. Sorry, I just have to go into Prisma. Okay. So let's do this migration. Edit user. Nice. So you can probably notice we are still using the older version of Prisma, so we still have like migrate save and that stuff, but we are now actually switching to the newest version. So this is soon going to be only migrate dev. Cool. So we did the migration, and then the next part. Let's go back to the code. We also have to add the login and sign up routes. So let us just quickly do that. Let's put it right here. So here you can see we have like route for the login, which is referencing the login page component, and very similar for the sign up, referencing sign up page component. So let's create those pages. Let's go with the login page, and let's just copy it over. Okay, so what are we doing here? We have a simple functional component, which is just putting a login form here and a message in case you are not yet, if you don't have an account yet. But the cool thing is actually here. So once you're using, you defined in Wasp, you're using authentication. Wasp is automatically for you providing this form, and you can import it in this special way. When you say add Wasp, you get access to this Wasp namespace and the stuff that Wasp already prepared for you. So this is actually like comes out of the box. And then it's going to be very similar for the sign up page. Just come to it. So yeah, here it is. Sign up page. Let me just, if I mess something up. No, it's good. Okay, great. So now we have those two pages. So let's see what else is missing. And we also have to add, yeah, I think that's pretty much it. Okay, great. Let's see what, okay, everything seems okay. And now let's see how it works. Okay, great. This is still the same, but now if we go to sign up route, yeah, we actually have the form which you can use immediately. So I'm just going to create an account. Okay, let's sign up. Cool, we are now signed up, but we cannot see it yet. So let's add some more logic so we can actually see who is logged in. And for that, we also have one cool feature. So, I mean, we are building a to-do app. So let's say we want to have it protected. It's only visible to the users who are logged in. And in this main page, we are going to have like all the functionality. So what we can do now, we can say that there is auth required to access this page. And if you're not authenticated, then you cannot access it. So, and we will also add actually here the sign out functionality. So we can try it out. Okay, so this is also a method provided by Wasp. So we can just import it. Let's add sign out component. Nice. And we can just here. Let's say above the logo. Okay, cool. So we should now show that we are signed in and give us a way to sign out. Oops, we are missing something which I forgot. And this is basically once you've said that authentication is required for a certain page, then you immediately get access to the user in this in the props of the page. So we actually have to use that. Cool. And so now it works, and you can see we are logged in. We can log out. And in case, so I'm now logged out, and in case I go now to the home page, I will just get redirected back to login page. So this auth required thing is working. So let's log in back. Cool. And the next thing I wanted to show you is basically how to create tasks and list tasks. So let's do this now. So the next thing we need to do, so we are going to have tasks, so we need to create a data model for tasks, obviously. So let's do this. To make it simpler, we are going to make tasks global. So it's not going to be per user, but let's say like all the users are editing one global pool of tasks, just to make it simpler for now. So we need to do another data migration right here. I missed an A. Great. And great, yeah, we have another migration. You can also see like all the migrations are actually here in the folder, and they get committed as usual to the versioning. And now let's continue. So now we actually come to another part of the, as I mentioned, like CRUD functionality. So we are going to need a way to create a new task. So in Wasp, this is done with so-called actions, which is like also often called mutations, but so it's the same thing in this case. So we are going to create our own create task action, which is going to be responsible for creating new tasks. And also like by saying this actually defines like which entities is this action creating. So this comes helpful for automatic refreshing and cache invalidation later. So we'll see how it works. Cool. So let's quickly create an actions file. It doesn't have to be actions, like it can be any file you want. Yes. So, and now we can just do like a simple function which is doing. Cool. So what are we doing here? We have a function which takes argument, which is pretty much provided by you. So any argument for like a description of the task, is it done or not? And context is provided by Wasp. And so pretty much context contains like all the information you need to work in the actions and queries. For example, like you get an access to the user and you can check if user is signed in or not, so you can protect the route. And also on the other hand, you get access to Prisma. So this context actually is just a wrapper around Prisma. So you can call database action to create a new piece of data. Okay, great. We created this. So let's see what else do we need. Now we need to add a way on the front end to do it. So let's see that now. Let's add a simple form. Let's just put it right here. Cool. So as you can see, this is just like a simple form. We are using state here to track the state of the input field. And this is basically just like description and a button to submit. Great. So let's also just put it right here. Okay, let's say it's going to be, and we will also have to use just here use state. And yes, another thing, now we also get to import. So this is kind of similar, this like, not having to do API. Wasp is also doing this magic for you. So basically we get this one. Once we have created this action task, we immediately get from in the namespace Wasp actions, we get the Wasp action create task, which we can import and immediately use on the front end. You can see it's being used here in the submit function of the form. And yeah, we're just giving description in there, and that's going to the database. Okay, great. I think that's pretty much it. So let's see if it works. Okay, all seems to be compiling. Cool. Now we can actually create tasks. So let's say task 1, task 2, hello. So we cannot see it yet, but I can quickly show you actually how it works in the studio, which is basically Prisma Studio, which also comes in very nicely for, for this need. So yeah, you can see actually here, like we have one user, which is me, and we have 3 tasks, which are the ones that we just created. Okay, cool. Yeah, so that's it. So I think we are pretty short on time, so I will not go through the actual creation of like displaying the tasks, but it's pretty similar. Like you just get to create a query. I can just quickly show it here maybe. So we would also get to creating queries right here and create a query get tasks. And then here is the cool thing. We actually say, hey, so this query is like, it depends on these tasks, task entity. So whenever this create task, like it affects an entity, it knows it needs to be refreshed and to get the latest data. And this is why also we are using here on the right side, we are using use query to ensure this reactivity in the component. So, and yeah, we just have like a queries file where we made a query, which is just doing the getting of the tasks. And also we can protect it. So it's only for authenticated users. So yes, and I will just go back to the presentation right now. Let's see here. So this was it. We built a to-do app. I showed you auth, and I showed you quickly how to create and list tasks. And just to finalize, like we have like a lot of stuff in the roadmap and like a lot of things that we would love to do, but are kind of still the vision. So for now, we are only on JavaScript, but we plan to very soon add support for TypeScript, more identification methods. Then we know also SSR is really important. And we also think it makes a lot of sense to add support for serverless because like this would be a really good fit. So you could decide like actually what you want, and also some themes, layouts, prototyping features to get you started faster. And like crazy vision is actually like support other stacks, because like we could do it because we are building this layer of language which can generate the code in different languages. Also, it would be cool to be able to mix like so you wouldn't go to like JS file and then reference it in your Wasp file. You could just directly write it in your Wasp files. Like one other cool thing would maybe like be a visual editor on top, so we could like make some things people could directly from browser or somewhere just edit specific parts of the app. And yeah, like probably what is much needed is like monitoring, management, performance monitoring. This is also what comes like with this whole stack. That's it. So how you can get involved? You can try Wasp out and give us feedback. This is super appreciated. We have Discord community, about 200 people. So it's really good to get your feedback there. You can also build your side projects and whatever you have in mind. People are using it now for hackathons. Do not use it like for super commercial stuff yet. It's in alpha, but like people are building stuff with it. And like whatever you build and deploy, we are going to give you a t-shirt. And at the end, yeah, if you like the product, you can just star us on a repository to give us support and join our Discord community. So yeah, that's it. Thank you very much. And we'll be happy to get any questions.
Matija, thank you so much for that. That was really cool to see in action. I'd heard about Wasp, but now we're seeing it in action. And yeah, let's open up the Q&A. So if you have any questions, feel free to use the chat. Something that came to mind when you were demoing was the fact that you're defining the the database schema essentially using Prisma schema, but within your Wasp file. I was curious, how does that sort of interplay with Prisma in terms of, say, syntax highlighting and things like that? Do you have any thoughts on that?
Exactly. I mean, as you could see, like we actually have a syntax highlighting in Visual Studio Code. My brother had like a lot of fun with making it work. It was actually easier than expected. But yeah, for Prisma, it wasn't so easy to get it out of the box because obviously like we are wrapping some stuff around it. So I think it's not working completely yet. It's like half working. But I think it could even be done because like this Prisma is declarative and has like pretty simple rules. I think we could just replicate. So we don't get it out of the box, but we could replicate it for sure.
Mm-hmm. And when you create entities that you can then interact with via CRUD operations in the front end, do you have the ability to control which fields you can actually modify from the front end? Like, for example, in the user entity, you probably want to hide the password field, or, even in the task entity, you might want to have some fields that you're not actually rendering or even sending back to the client. How is that kind of logic defined?
Exactly. No, good question. I mean, right now, even with the authentication method, like when you say like this is going to be email and password, we immediately know that you have to have a password field, and Wasp is immediately taking care not to send it back to the front end. So this is now like pretty rigid in this way, but we also plan to add like more roles and access control lists, functionalities, especially to backend as well. So you will be able to say like this field is protected, this field should never go to the front end. Like, so all of this makes sense, and yeah, we plan to add that.
Gotcha. Cool. Well, we have no questions coming in, so I'd like to thank you again. The Wasp website can be found at wasp-lang.dev. Is that the correct URL?
Yes, that's it.
Okay, cool. So I'll drop that in the chat. And once again, thank you, Matija.
Thank you for having me.
All right. Oh, we're now about to wrap up the meetup for today. And also I'd like to share one more thing. So this week on March the 11th, we're going to be hosting another live stream with Ryan Chenke, who you might know, who's another developer advocate on the Prisma team. And he's going to be interviewing Matt Muller, who's one of Prisma's product managers. And they're going to be discussing all about transactions. So many of you in the Prisma community have brought up the necessity of transactions in Prisma. And while Prisma does support transactions, there are still some situations in which you can't do things like long-term transactions. And so I really highly recommend you to tune in, and you can find that. It's already scheduled, so you can go ahead and already set a reminder. And on that note, I'd like to thank you for tuning in today. It's been a pleasure having our three twins give us different talks, and we hope to see you at the next Prisma meetup. So take care.